I hope you are well. William here, presenting from beautiful Krakow, Software Mansion, Expo. Thank you so much for having me today. These are some of the content creators, open source contributors, and indie makers who are pushing the boundaries of what it means to build a great React Native user experience. People like Enzo Mangano, who's here in the audience today. Enzo is known as a React Native Skia expert, and he's recently been experimenting with React Native WebGPU to build new, innovative kinds of renderings. People like the one and only Daeon Moon. Daeon has built some of the most incredible user experiences using React Native, and he is, in fact, an award-winning React Native developer. People like Ivo Plaza and Konrad Rechko from the TypeGPU team at Software Mansion, who are also here in the audience today. Recently, Ivo and Konrad have been experimenting with Redraw to build this beautiful TypeGPU logo animation. Project Redraw is also using TypeGPU itself. And so here they are using geometry-aware shaders written in TypeScript to build that animation. So, WebGPU. The beloved web standard and React Native WebGPU was introduced here on stage at App.js. Skia, arguably the world's most advanced 2D library, and we created the library with Christian Falk, who will also be giving a talk tomorrow here on stage. And Redraw, a new grade of 2D primitives. It's a new leap we are making as to say, can we make a contribution to what it means to have state-of-the-art 2D graphic? As you can probably tell already, the opportunities to build user experiences that will create a sense of wonder and delight to your users are rich. This morning, I have an update for every of these projects, and we start with React Native WebGPU. When we got started with React Native WebGPU, one of the goals was to be able to copy-paste a WebGPU example from the web directly onto React Native. It should just work out of the box. And so, for instance, here we are configuring a WebGPU Canva. We copy-paste the example from the web. When you copy-paste the example from the web, there is one big invisible difference. Is that on the web, by default, you run on the presentation thread, and here we run by default on the JavaScript thread. And the way we needed to fix this difference is by adding a new API call, context.present, that lets us notify the UI thread that a frame is ready to be presented. So this line of code here is in React Native only. It's not part of the JavaScript WebGPU standard. We thought, OK, it's not so bad. It's just a tiny line of code to add. But it actually gets much trickier if you use third-party libraries. So for instance, here we use free fiber. And you see this crazy onCreating callback here. It's just so we are able to plug in the context.present call within the API. So this is where you see things start to look a bit awkward. And we are refining our understanding on how to do the presentation rendering in WebGPU. And so finally, we are able to remove the context.present. It just works like on the web. We follow the symmetry with the web. And here to React Free Fiber, this is the same. As far as Free Fiber is aware, this is the same as rendering on the web. Now, in React Native, if you want to go from the JavaScript thread to the UI thread, you're going to use an API. You're going to use reanimated worklets. And WebGPU is a bit of a special case, because the library is so low level. If you don't bring any of your NPM packages with you, you're not going to go very far. You need to do matrix operations, uniform padding, TypeGPU, FreeJS. If you cannot bring your NPM packages with you on the worklet thread, you're not going to be able to go very far. And the reanimated team at Software Mansion has been working on a new feature, which I'm pretty excited about. It's called bundle mode, and that feature allows you to do just that, to bring your React Native bundle with you in a worklet thread. So let's have a look. Here I have a Three.js scene running, and you see the little blue square running. The square is running on the JavaScript thread. So if I toggle the make JavaScript thread busy, you see the little square stopped turning around because the thread is not available anymore, but my 3D scene runs nicely. So that's bundle mode. It's an experimental feature. Oops. The way we also integrate it with WebGPU is also somewhat experimental, but these kinds of user experiences are going to become mainstream very soon. So we follow the symmetry with the web, and we see where it leads us. And on the web, people use WebGPU to do video processing. This is what people are doing on the web. And they do it using an API named import external texture. It's an API that allows you to import a camera feed or a video feed, and they do it extremely efficiently. The YUV to RGB conversion is handled on GPU, works everywhere. It's extremely easy on the battery life. This is what people are doing on the web. So that's what we're going to do. Let's have a look. So here I have my React Native WebGPU example app. And I'm going to play a video feed, which I'm going to import into WebGPU. I'm going to do three things. I'm going to apply some shaders to do color effects and color filters. I'm going to do resize the video using a shader. And I'm going to sample the video texture to apply effects like blur or liquid glass material. Let's have a look.
OK, time for our pregame ramen. Happy fans, happy
So I'm applying color effects here.
Wait, there's no water in these.
Excuse me, miss?
Yes, Miss Hunter. Hicks?
We asked for hot water, like...
Right away. You're welcome. Arrivederci. Goodbye.
OK. Hi, Bobby.
Yeah, hi.
So here I'm sampling the texture. The buttons are not an overlay. I'm sampling the texture to build the liquid glass effect.
Just got this!
Sick.
I can resize the video.
Late?
50,000
And now I can blur the texture behind to build this beautiful ambient mode effect. That's an effect you will find on YouTube, for instance.
We'll be there in 3. Oh, I didn't even get to finish my damian!
Why do they always interrupt our snacking?
So that's import external texture. Works on iOS and Android. It's done extremely efficiently. The YUV to RGB conversion is done completely on GPU. It's extremely easy on the battery life. We use Dawn, the WebGPU implementation from Google, and they do all of the heavy lifting for us here, including having this supported on Android, which is to have this supported on Android is quite a technical feat. So we're very excited about this. Now, so this is a video feed. We can also import a camera feed. What are we gonna? We need a camera feed. What are we gonna use? We're gonna use, I think, the gold standard React Native Vision camera. And we're gonna import the Vision camera feed into React Native WebGPU, and I'm gonna do 3 things with it. First, like you saw with the video, I'm gonna apply some effects, do some blurring, typical color filters, and so on. Then I'm going to use to apply machine learning models like TensorFlow.js to do things like face detection. And finally, I'm going to, let's see what the third one is. So here, same story. I have a camera feed with Vision camera, and I can apply typical shader effects, chromatic aberration, blur, you name it. This example is running TensorFlow.js. So I'm loading the model here, and it does face detection automatically. This is a pure JavaScript user experiences. So just like on the web, I'm importing the model, I'm importing TensorFlow.js, and I just integrate it with React Native Vision camera. And for the third demo, I'm going to try to go live. So let's have a look. So I have my phone here. And so this is the React Native WebGPU example app. And I'm going to load the 3GS model. So you see here, the back camera is the background of the image, but the reflection on the helmet is actually the vision camera. I don't know if you can see my face on the, or you guys can see yourself on the. Isn't that cool? Is Flutter doing this? So that's the integration with React Native Vision Camera. And Vision Camera implements an API named Native Buffer. It's an API we designed with Mark Roussavi, and the goal was to be able to integrate without statically linking against each other, plug and play between different modules, Vision Camera, video, Skia, WebGPU, and so on. And so we can import it directly into React Native WebGPU. When we came up with this design, we encourage people who have an NPM module which does video or camera feeds or native view snapshots to implement this API so it can be integrated at zero cost with WebGPU. And in fact, when we implemented the import external feature, we didn't even have to make any modification to Vision Camera. It's plug and play, just works. Now there is another API. So all you've seen so far is read-only. And there is another API where you can write into the texture in case you want to do things like video encoding, for instance. Now, when we announced React Native WebGPU here on stage, I was very excited. Oops. The clicker is OK. And I was so excited that I forgot to register the package name on NPM. So I had to name the module React Native WGPU. And I didn't help with the confusion, but so the project name on GitHub was WebGPU. There is a WebGPU implementation which is named WGPU. And there are packages that depend on React Native WGPU, which use the WebGPU suffix. So this was a very confusing situation. And so today, React Native WGPU becomes React Native WebGPU. Now, that's a game changer. One of the goals also when we introduced React Native WebGPU was to modernize the Skia, React Native Skia architecture using a new backend of Skia named Skia Graphite, which runs on top of WebGPU. So on Android, instead of using OpenGL, we use Vulkan. We do it through the WebGPU API. And because we have a unified runtime across libraries, we can run libraries like 3GS and Skia together. And we do it, this can be done through two APIs. So you have an API where you can, at zero cost, use a WebGPU texture directly into Skia, and as well bring a Skia image into a WebGPU scene. So here I have a 3D scene built with React Native WebGPU. But now at zero cost, this scene can be part of a 2D Skia scene. So the text layout, the path clipping, the backdrop filter are all done with Skia. So the 2D world and the 3D worlds are composed together at zero cost. So here, a similar demo, the text layout, font rendering is done in Skia, but at zero cost because it's a unified runtime. I can use it into a 3D scene. Here, another example. So that's our little helmet here, which is done with 3GS. So 3GS is based off class 3D library. But to build the futuristic UI, we use best of class 2D library, which is Skia. So again, here you have Skia and 3GS working together on the same unified runtime. So that's Skia Graphite. And here you can see the little cube. We put it all together. So you have video feed, path rendering. It's all under the same runtime. So Skia Graphite is available under the @next distribution channel. It's still very much experimental. It's a steep migration process. So currently, it's completely experimental. We think that in the fall, this will be the recommended user experience for people who start with a new project. And by the end of the year, we hope that Skia Graphite will be a candidate release. That would be React Native Skia version 3.0. Now, we still work, of course, on improving the main React Native Skia trunk. We are working on a couple of improvements. I've picked one for you this morning. So in this demo, we use a feature which is called native view snapshot. So the view that you're seeing are React Native views. And we take a snapshot of each view to do this nice transition. And so this is on iOS, works perfectly. But on Android, if you use complex views, so here, for instance, I have a web view, I'm using card elevations, and there are like potentially some complex React Native layouts that you would do, we wouldn't be able to get the exact pixel perfect snapshot on Android. So here, if I run the demo, you see that it actually looks very buggy. So this would only work if you have a really simple user interface between React Native. And so we look at each platform, iOS, Android, web, and we see what are the best practices there, what does the platform gives us, and of course, if there are novelty, we try to leverage them. So on iOS, no problem. On Android, it's extremely buggy to almost, I would say, a point of no repair. And on the web, there is nothing really you can do. So we look at the platforms, APIs, and we see if there are novelties we can use to solve our problems. On the web, there is a new API named HTML in Canva. It's an experimental feature. Works only on Google Chrome behind the flag. And this is an incredible API. It solves tons of problems, including the snapshot view API. So this is potentially a solution that can be used. On Android, there is a new API named Hardware Renderer, API level 29 or above, which we can use to get a precise rendering of the native view to ship it to Skia. So here we have the exact same demo, but running on API level 29. And you see now we get the pixel perfect rendering. I have to give a shout out to Kim Brandvik, who pointed me to this new API. Kim is also the maintainer of React Native WebGPU camera, where you can use Skia Graphite and native camera, as well as machine learning models to build incredible user experiences. So I recommend you check it out. And I am also coordinating with Gaëtan Renaudot, the maintainer of React Native ViewShot, so we can share the best practices here on how to get the best native views, because this is useful outside Skia. We use it in WebGPU. There are many use cases for it. So we're coordinating together to see how we can share knowledge and integrate together nicely. Skia, c'est un peu le joyau de la couronne. It's the crown jewel of 2D graphics. And when we introduced React Native Skia, we showed an example that looks like this. We draw a path. We have a stroke width and a color. And the stroke width is a number. That's it. And I always, instead of passing a number as a value, I always wanted to pass a function instead. So instead of passing a number, I'm passing a function. That function receives geometric information as parameter. So here you have the context variable, and we can describe a curve. Here we do a sine curve, and you see context.t, it's the arc length of the path. It's a value that goes from 0 to 1. At 0, you are at the beginning of the path. At 1, you are at the end of the path. And you can do a sine wave, and that gives you this beautiful variable stroke along the path. This was my fantasy. Same for colors. Instead of passing a single color or a simple gradient, I always wanted to pass a function. That function receives geometric information as parameter. And so, for instance, here we interpolate a palette of color depending on the arc length of the path. And that gives us this nice gradient along path variable. This was always my fantasy. And this is exactly what Project Redraw is. That's a new project I'm starting, which runs on top of WebGPU, so it integrates at zero cost with libraries like Skia and WebGPU. And you see these use GPU directives on the source code means that these functions are compiled and executed on the GPU using type GPU, which is a project from Software Mention. So the same way Software Mention came up with a way to execute code on any arbitrary threads with reanimated and worklets, Software Mention came up with a way to execute and compile TypeScript code to the GPU. And you can use that geometric information, so arc length of the path, distance to the path, tangent to the path, to build any sorts of crazy renderings. So here we build the liquid glass effect, because all the information is available to you. So you can build any sorts of effects. The sky is the limit. So this is still very much experimental, but I set up a playground. You can try the feature, and you can paste any SVG path you would like, and you can, instead of having simple colors and fixed stroke width, you can experiment and build all sorts of interesting effects. There is, so I mentioned stroke width, color along path. There is a third property which are called vector favoring. So you see the blur that you see here is not done using an average of the pixel. It's not done using rasterization. It's computed directly using the vector information. And this has a couple of, okay, so you can build some beautiful glow effects and so on, but it has a couple of interesting implications. First, so if you build a soft shadow user interface such as this one, it's using so many inner shadows and outer shadows that you actually drop frames pretty quickly, because you have to do so much rasterization. But if you build the same user experience where you use a vector blur, so zero rasterization is involved, you will run at full frame rate. So the performance is very, very good. It also enables a couple of use cases I'm pretty excited about. So this is called analytical motion blur. I'm moving the sticker around, and you see it's blurring as I move around, and you have like some chromatic aberration as you go along. Before, you wouldn't be able to do this because you would have to do the rasterization step, and you would have to blur depending on the velocity and the direction of your finger. But here, because everything is computed in a single pass, it's very fast and it works very precisely. So I'd like to go back to the soft shadow example. So this is how the design looks like in Figma. And it's actually pretty crazy. So here for this little button, I have 3 inner shadows. And for each inner shadows, you have tons of parameters. And you have to do this for every element of your design. I don't think these are realistic expectations. I watch tutorials where you see people painstakingly building these designs manually. It takes forever. I don't think this sets a realistic expectation for developers and designers. What I believe is that instead, people are going to build flat user interfaces, such as this one, and they're going to set the temperature on how realistic they want the rendering to be. So here the rendering is completely done procedurally. I didn't have to set any shadows myself manually. You just set the temperature on how you want the design to look like. A bit like you would do in a 3D system, but here using the SVG paths you know and love. So that's how it looks like. And that's what I wanted to show you this morning. React Native WebGPU, we're implementing support for camera feeds and videos. It's extremely easy on the battery life. It's done extremely efficiently. Skia Graphite, a unified runtime between Skia and libraries like Three.js. It's a steep migration path, but we're working on it. And Project Redraw, a new grade of 2D primitives, a new leap we are making to build new kinds of 2D primitives. This is our vision for computer graphics in React Native. Thank you, Shopify, and use the community for supporting it. Now, so, hello? OK. Now I'm not done. There's one more thing. Now, every April 1st, I like to make an April Fool's video. It's always a joke, but I always put a technical nugget within the video. 2 years ago, I made a Binging with Babish parody, where I wanted to build a 3D cake slice using React Native Skia. This was very hard to do because Skia is a 2D library, so it's not really made to do 3D things. And I was incredibly frustrated because I knew that behind the scene, Skia runs on top of 3D APIs. So I knew these 3D APIs existed, I simply couldn't access them. So I was quite frustrated, and this is when it became clear that WebGPU was the way forward. So from a place of fun and silliness, something very serious came out of it, React Native WebGPU. Last year, for April Fools, I wanted to give an homage to the Queen's Gambit series by exploring non-destructive geometries and things like SDF. This was extremely fun to do, but I remember after finishing the video telling myself this was completely useless. This didn't help anyone to build a better app. And then I told myself, well, what would happen if we apply all of that we've learned making the video, all the recipes that we've learned, what happens if we apply it to 2D user interfaces? And the answer to that question is Project Redraw. What you saw with Project Redraw is applying all of these recipes to 2D user interfaces. I like these examples to remind myself that unproductive times never fail to end up being the most productive ones. All of this work is a cycle between making a new leap and massaging the octopus. With React Native WebGPU, this was a new leap we were making, and then after it was time to massage the octopus. Obviously, with Project Redraw, I am making a very big leap. It's a big swing. So I'm going to need to massage the octopus extra long on this one. As I do, I'm going to keep you posted every step of the way. And so indeed, I am looking forward to talk to you soon. And until next time, happy hacking.